We're going to start today's lesson with this word problem about Mr. Short and Mr. Tall. So let's first read the problem. The length of Mr. Short is 4 buttons. The length of Mr. Tall is 6 buttons. If you look at the picture on the bottom, I have Mr. Short here being 4 buttons tall and Mr. Tall being 6 buttons tall. When paper clips are used to measure both men, the length of Mr. Short is 6 paper clips. What is the length of Mr. Tall in paper clips? On the bottom you see I have here Mr. Short, he's 6 paper clips tall. So we have to figure out how many paper clips tall Mr. Short is. Can you please pause the video and give me your guess? Before I explain to you the way that I solve this problem, I have to double check that you know a couple of vocabulary words. The first word is rate. A rate is a comparison of 2 measurements. Rates can be written in 3 different ways. The first way we can talk about rates is by using words, short to tall. We're comparing Mr. Short to Mr. Tall, so we can use words. The second way is to use a colon, which basically is used in place of the word to, like in this second example. This says short to tall. We're comparing Mr. Short to Mr. Tall. Another way that we can write rates is as a fraction, this last way. We're comparing Mr. Short to Mr. Tall. Our next vocabulary word is proportion. A proportion is a comparison of 2 rates set equal to each other. Well, in this way, we're going to use rates as a fraction. So basically, it is a fraction that equals a fraction. What I have set up here on the bottom is a fraction that equals a fraction. So let's think of a simple example that we can use. What is a fraction that we know? Well, I know that 1/2 is a fraction, which if I were to talk about it as a rate is 1 to 2. 1 to 2. So what is a rate that equals 1/2? A rate that equals 1/2 is 2/4. 1/2 equals 2/4. If we try to put this in a picture, you would see that 1/2 does equal 2/4. So you could see here 1/2 of this circle is the same amount shaded as 2/4 of this circle. So let's see how we could use setting up proportions to solve our next problem. So right here we have Mr. Short and Mr. Tall again. So let's review things that we know. We know that Mr. Short, when we measure him in buttons, is 4 buttons tall. We know in comparison, Mr. Tall is 6 buttons tall. We also know that when we measure Mr. Short in paper clips, he is 6 paper clips tall. We need to figure out the length, how tall Mr. Tall is in paper clips. So think about what we learned about rates and proportions. What we're comparing is Mr. Short and Mr. Tall. So let me write that first in words. So writing my proportion in words makes sure that I'm organized when I'm putting my information. All my information about comparing Mr. Short will be on the top, my numerator, and all my information about Mr. Tall will be on the bottom, my denominator. So let's think about a ratio we can write about the length of Mr. Short and Mr. Tall in buttons. Well, I know Mr. Short is 4 buttons tall in comparison to Mr. Tall's 6 buttons tall. I also know when I'm thinking about paper clips, I know that Mr. Short is 6 paper clips tall. So I'm going to write that on the top. I do not know the length of Mr. Tall in paper clips. So what I'm going to do right now is I'm going to write that as a variable. It's an unknown. I do not know how Mr. Tall is, so I'm going to put a letter T for my information right now. In my comparisons, Mr. Short is still the same height, no matter if I'm comparing his height with buttons or paper clips. So the height of Mr. Short is the same both times. Also, the height of Mr. Tall is the same no matter if I'm comparing him in buttons or paper clips. So this is something that we could set equal to each other. We have now made a proportion. Remember, the definition I gave you for proportion is two rates set equal to each other. Well, I do have rate here, the rate of Mr. Tall and Mr. Short in buttons, and this is another rate, the proportion of Mr. Short to Mr. Tall in paper clips. These will set equal to each other. Now let's talk about how we'll solve for Mr. Tall. Right here we have our proportion again. 4/6 is equal to 6 over t, and we're solving for t. Our next step is to find out what t is. We currently don't know what it is, so our step is to cross multiply the diagonals. So we're going to multiply 6 times 6 and this 4 times t. When you do this, 6 times 6 is 36, and 4 times t is 4 times t. We can't write that any other way, so we put it right next to each other. This means 4 times t. We're going to bring that equal sign straight down. So now we went from a proportion to an equation. This says 36 equals 4t. To solve for t, we have to get the t away from 4. The way I like to talk about it is that numbers and letters don't like to be friends a lot in math. So what we need to do is separate them. The operation happening between this number and letter right now is multiplication. So to do the opposite, we have to divide. Dividing by 4 will take away the 4 from this equation. Because if we do this, 4 divided by 4, that equals 1. So we could write 1t right here, but we know that variables don't need that 1 on the top. So this has now become a t. On equations, when we do something to one side of the equation, we have to do it on the other. We divided this side by 4 to get this 4 to be a 1, and because we did that, we now have to do that over here. So divide this side by 4. "36 divided by 4 would equal 9. So t equals 9. So that means that in our equation where t is, we could now put the number 9. Now we did a lot of work. What does that 9 stand for? Do you remember? We were comparing the heights of Mr. Short and Mr. Tall. The 9 tells you how tall Mr. Tall is in paper clips. So Mr. Tall is 9 paper clips tall. This is one way you could solve this problem.